Okay, this is the our last class meeting where I will conduct the second half of the final exam review. So the first part of Monday was about the chapter 5 lessons on the logarithmic and exponential functions. So today will be about the chapter 6 lessons on indefinite and definite integrals. So get the old screen share going one last time. Okay. This is actually the kind of document I meant to present on Monday, but there were some technical issues, so I'll have one prepared for the first half and post that too. So first we just have a review of all the different rules for evaluating integrals, starting with this one is used most often, the power rule for handling powers of x, except for 1 over x. Constant factors, you can pull them out. If you have an integral of a sum, you can break it up into a sum of integrals and evaluate these two individually and add the results together. If you have 1 over x, that's the integral of that is natural log of absolute value of x. You must remember the absolute value or Hawks will mark it wrong. And then e to the x, which is its own derivative, is also its own integral. But if you have e to a constant times x, you must remember to divide by the coefficient of x. And that's something that will definitely come up in some problems. So these are the rules that you will use for evaluating indefinite integrals and just getting antiderivatives in general. If you have a definite integral where there are numbers given here as the lower and upper limits, you still get an antiderivative using these rules. And once you have it, you substitute the limits in, and so you compute antiderivative at b minus antiderivative at a. And your answer is a number for the definite integral. For problems involving the average value, as you'll see, you'll actually evaluate this, and then you have to remember to divide by b minus a. So that's something we'll see a little later. Okay, so getting to the problems. So these are the final includes a selection of problems that you saw in the homework from these lessons in chapter 5 and chapter 6. So it's these problems that I'll be reviewing now. So here we have an indefinite integral to evaluate. So 3x to the minus 2 minus 8. So because we have a subtraction going here, we can write this as a difference of integrals. We have a constant that we the integral of 1 is just x, and then with the x to the minus 2, we'd use a power rule, and that would be sorry, my text here is so small, it's very difficult to work with. So to show clearly how the power rule is used in this case, so that would give you x to the minus 1 over minus 1. So you add 1 to the exponent, and then you divide by that new exponent. But x of minus 1 is the same as 1 over x. So this is equivalent to minus 1 over x. So then we just clean up the constants. And it doesn't really matter how you write it, as minus 3 over x or minus 3x to the minus 1. Either way, as far as Hawks or myself is concerned. So that's your final answer. And once you evaluate an indefinite integral, again, indefinite, don't forget to plus c. or Hawks will mark that wrong. Now, in this case, the way the integrand was written was as x to a negative power. If it's not written that way, for example, suppose you have like 1 over x cubed, then it's best to write it using a negative exponent before you apply the power rule. Just like when you take derivatives, it's the same idea. Feel free to interrupt at any time if you have any questions.
Where you get the fraction?
I'm sorry, I could not.
So what we get the fraction?
Okay, I heard fraction. I could not really hear anything else. I'm sorry.
From what did you get the fraction?
Oh, this?
Yes.
Yeah, x to the, from here. X to the minus 1 is exactly the same as 1 over x. So it's just this being rewritten. So this is what you have to keep in mind. Really, wait. Considering a form of the final answer is written in, these 2 steps aren't really necessary. Again, let me be clear here. It does not have to be written as a fraction. It can be written as a negative exponent like here, or as a fraction, using this. It does not matter. First, next one, also an indefinite integral. We have a sum of a few terms, so they can be broken up. Again, you don't have to do it that way. I just like to have the simplest possible thing to integrate, just to show you the process. So within each of these, we have constant factors that we can pull out. It was 7 for this one, the 9 for this one, the 2 for this one. For this one, we can use a power rule. Again, you add 1 to the exponent, divide by that exponent. Here we have 1 over x. Here you do not use a power rule. The integral of that is natural log of absolute value of x, so that's what goes here. Here again, power rule, add 1 to the exponent, divide by that exponent. Be careful when it's negative numbers. I've seen students go the wrong way. Like if you have x to the minus 9, like here, I've seen some do something like x to the minus 10. So it's minus 9 plus 1, that's minus 8. So be careful with that. Then it's just dealing with a constant. So we have 7/8 here. And then we have 2 over minus 8. So that's where the minus 1/4 comes from. And then we arrive at our final answer. Here's another one involving exponential. It's missing the integral sign here. Let me put that in here. Okay. Okay. Same process as last one. Break it up the different terms. Pull out any constant factors. So we're left with integrating e to the x, x to the minus 5, and 1. E to the x is its own integral. So it's just e to the x. X to the minus 5 we use the power rule on. Again, careful with negative numbers. So it'd be x to the minus 4 over minus 4. And then the integral of 1 is just x. That's called the constant rule. So then we just clean up the constants from here. And there you have it. Okay, first word problem in this set. Long ago, dealing with derivatives, you would be given a cost function, and you'd have to take the derivative to get the marginal cost. So here we're going the opposite direction. You're given the marginal cost, and the goal is to find the cost function. So the integral of marginal cost is cost. So since this is a given marginal cost, that'd be the derivative of cost. So we start with that. So to recover the cost, c of x, that would be the integral of the marginal cost. So integrating and differentiating, those are inverse processes. They basically undo each other. So here we fill in the marginal cost, and then we take the integral of it. So the 20 just gives us 20x. And then here with x, we have a power rule. So this is x to the first, so we get x squared over 2. And then we clean up the constants, and we have almost entirely specified our cost function. It's not complete because we have this plus c, and this is an arbitrary constant. We needed to get an actual value for it this time. And this is where the other information in the problem is taken into account, that the fixed costs are $2,500. So fixed costs, dang it. Or C of 0, because X is how many units are produced. The fixed costs are what you have when you don't produce any units. So what you would get if you plug in X equals 0. So we have to make sure to choose the value of C so that if you plug in X equals 0 here, the overall expression will equal 2,500. So we go ahead and set X equals 0 in here, and this is what we get. The other terms go away, so we're just left with C. Now, C of 0 is set equal to 2,500 for the purpose of solving for C, and we find that C is just 2,500. So this is a cost function fully specified. So if you plug in X equals 0, you get the fixed cost of 2,500. Also, if you take the derivative of this, well, the derivative of 2,500 is 0, so that wouldn't give you anything. And then the derivative of this would be the marginal cost that you were given. All right. So take the integral of marginal cost, get this incomplete cost function, set X equals 0, set that equal to the given fixed cost value to obtain the value of C. You fill that in up here, and that is your cost function. Here we're using the fact that velocity is the derivative of distance traveled. So now we're going the other way, but we're in previous problems we were given a distance function and you had to get velocity. Here we're given a velocity and you figure out distance. So here we take the given velocity and we take the integral of it to get a distance function. So this is the same idea as in the previous problem involving marginal cost and cost. So we work out the indefinite integral by breaking this up and handling each term individually. Integral of t would be t squared over 2. Integral of t squared would be t cubed over 3. Don't forget the plus c. So this is our distance function, but incomplete. We have to make sure that based on this is something that's given in the problem, that if you plug in t equals 0, you must get 0. So we set s of 0 equal to 0, and then we fill in what s of t is down here. Set t equals 0. The only thing we're going to get is c, but since the whole thing must be equal to 0, we end up with this result, that c itself must be 0. So that would be the distance function. So it satisfies the condition that if you plug in t equals 0, you get 0. And if you take the derivative of it, you get the velocity function that you were given. That's a good way to check your answer for a problem like this. So after you get to this point, if you want to make sure that it's right, check the conditions. If you plug in t equals 0, do you get 0? If you take the derivative of this, do you get velocity? So if time permits, that'd be one way to be sure about your answer before you submit it.
So the interval that they gave at the beginning doesn't really matter within this problem?
Yeah, I don't know why they do that. Because occasionally there are problems where it does matter, but not for this one. I think the only problems where that matters is if it's a problem finding a max or min, because then you would use the endpoints as candidates. But otherwise, yeah, you could ignore that. I have to talk to them about that because it throws you off. You're so conditioned to think, oh, I must use every single piece of information that's given, and well, not anymore. So if you ever part of a problem, how far will it travel in 7 minutes? So for that, you substitute in t equals 7. So you just grind it out on your calculator and get your result. Okay. So the first 5 problems in the set were about indefinite integrals. The last 5 will be about definite integrals. Okay. So here's our definite integral. We limits of -3 and -2. So you started out the way we've been doing the previous problems, just taking the indefinite integral. So here we pull out the 7, and then 1 over x cubed is rewritten as x to the -3. So I recommend that when you're about to use the power rule for derivatives or integrals. It's good to write in this form. So then when you apply the power rule to x to the -3, you get x to the -2 over -2. And then, again, this is optional, but you can rewrite that as using a fraction, that x to the -2 up top is the same as x squared down below. So here we have our indefinite integral. But now what we have to do is substitute in the given limits. -2 is the upper limit, and then -3 as the lower limit. We don't bother with a plus c here because you're subtracting these values. So the plus c would cancel out anyway. So you can ignore that when it's a definite integral. So here we just substitute in limits, -2 over here, minus the value at -3. And from that point, it's just working through the algebra in this case. And here they give you a choice. Give your answer in exact form or rounded to 2 decimals. Actually, I wish they give that choice on more problems. So here the answer is given in both of those forms, but you can use 0, 1. So you can either just work this out on your calculator and round it to 2 decimal places, in which case you'd enter this, or you can work out the fractions and put everything over a common denominator and get this form. But that's up to you. But in general, be sure to pay attention to what they say as far as how the answer is to be specified. Are you rounding to a certain number of decimal places? If they don't specify that, that indicates that they want an exact value, such as a fraction. Okay, here we have another definite integral, and see what they specify for the form of the answer. So we break this up. The 2 integrals of 1 and then e to the x. So the integral of 1 is just x, and then e to the x is its own integral. So here we have our indefinite integral. So now we have to substitute the limits, x equal 5 and x equal 4, and subtract. So that is carried out here. So you could use our keypad to enter the answer in this form, or you can work this out using the e to the x function on your calculator and round to 2 decimal places and get this. Okay. Average value. So here you're given a function and you're given an interval, and the goal is to find the average value of this function on this interval. So this is a formula that you're going to use. So you would take the definite integral of this function over this interval. So this will give you the limits 3 and 4. And then you have to remember to divide by b minus a. So just like before, we're going to do this definite integral. Just have to remember to divide at the end. So we work this out in the usual way. So 2 times the integral of x plus 4 times the integral of 1. And after using a power rule, this is what we have for our indefinite integral. So now we have to plug in the given limits 4 and 3 and subtract. So that is the definite integral. So then we use this formula for the average value. So the definite integral turned out to be 11, and we need to divide by b minus a, which is not very interesting in this case. It just happens to be 1. And that is our result. So that is the average value of the function over, I apologize, there's a typo here. It should be a as the lower limit and b as the upper limit. And same down here. I'll have to fix it on my old notes too. Okay, and the actual math that was carried out is correct, but the way the formula was written was wrong. All right, so upper limit, the greater value up here, the lesser value down here. But still, this is what you do. Upper limit plugged into your antiderivative minus lower limit plugged into the antiderivative. All right, here's another average value over this interval from -4 to 3. So then we have 8 times the integral of 1 plus 5 times the integral of e to the minus 0.6x. So remember, when you take the integral of a function like this, e to a constant times x, you must divide by the coefficient of x. You're dividing by minus 0.6 in this case. So then the constants worked out. 5 divided by minus 0.6 turns out to be minus 8.3. Okay. Wait a minute. Okay, I need to clarify. This is not simple. This is 8.3 repeating. Okay, and all of these other 8.3s are supposed to have that. Sorry about that. Okay. Okay, so once you substitute the limits and subtract, then this is what you get. So it's, now Hawks doesn't really provide a convenient way to write a repeating decimal. So how it could be written, I'll just fill it in down here. Because you recall the original fraction was 5 divided by minus 0.6. Okay. So that would be the same as 50 over 6, or I can reduce that to lowest terms, 25 over 3. Okay. So we use a formula for average value. We just have to remember to divide by b minus a. So the value of the definite integral is substituted in here. Okay. And then the difference between the limits is 7, so you have to divide the overall result by 7. Okay, so we have and rounded to 2 decimal places. This is the final result. Actually, wherever we have these 8.3s here, I apologize. I'm going to just replace those with fractions since that's exact. Questions about this one? Okay. Last problem. All right, here we have the daily production level. So this is the number of units where X refers to hours during which production has been taking place. So what is the average production during the first 4 hours? So average value. So average production would be so it's the average value of this function over the interval from 0 to 4, because you're starting at time 0 and then you're ending at time 4. So what's the average production during that interval of time? So we proceed the same way. We need the indefinite integral of this function first. So we have 180 times the integral of 1 minus 180 times the integral of this exponential. So then we get 180x minus 180 times the integral of this, which is itself, again, divide by the coefficient of x. That's where the 1 over minus 0.5 comes in. And then minus 180 over minus 0.5 happens to be 360. So here we have our indefinite integral. And then the limits are 0 and 4, so you plug in the value at 4 minus the value at 0. Remember, e to the 0 is just 1. So for this value, we're subtracting off 360. This turns out to be, let me simplify this a little bit. So you have 360 plus 360 e to the minus 2. All right. So that means taking that should be a minus. Okay. I can use the fact that I simplified it up here. I already took that into account. Okay. Okay. So this is where we get 90 plus 90 times e to the minus 2. Now, what form do they want the answer in? Rounded to the nearest whole number, or an exact form. So this would be the answer in exact form. Or if you work this out in your calculator, what you would get is 102, like 0.18, et cetera, but you're rounding to the nearest whole number, so that would end up being rounded down to 102. We've actually come to the end of these problems. Are there questions about any of them?
Can you go back to number 18 really quickly?
Yeah.
Okay, I got to the step where you find the actual integral, but when I tried to subtract it based on the little endpoints, I don't know, I'd messed up. So let me look at it really quickly. Oh, so on that one you would be multiplying by 1 since the fraction.
Oh, this part?
Yes, sir.
Okay. Yeah.
Okay, I see it now. Okay,
All right,
thank you.
Yep. Okay. Other questions? Okay. Soon I'll be sending a message in Canvas that has the password for the final, so please be on the lookout for that in your Canvas messages. And I'll get all the notes that I have posted in the Canvas discussions for this week, so you can refer back to these.
When's the test due?
Um, okay, the test, the final, long time since I said the due date, so I want to be absolutely sure I'm not giving wrong information. 1 second, please. Come on. Okay. Thursday, December 3rd, at 11:59 p.m. That is when the final is due.
What day would we be able to access it?
Oh, it's actually accessible now. I just have to send the password, and I'll send it out later today.
Oh, okay, thank you.
Well, tell you what, for those of you those very few of you who actually showed up, okay. Watch the video later. Okay, so that's the password. Let me check the chat here. Laura. Someone just left. Like 1, 2, 3, 4, 5. Okay, fine. Yes, I'll give some bonus points. Okay. I better hurry up and get the list of people who since one of them left. But they suffered for the whole thing, so they can get points too. Okay. All right. Best of luck in the final. And of course, you can contact me if any difficulties or questions to the very end. So over a weekend after the final, it's like December 5th or 6th. Should be able to see in Hawks or Canvas what your overall grade will be.
Have a good grade.
You do. let's see. I haven't thought about that yet, since there will be regular class meetings. I will be here in Teams at 9:30 on Monday and Tuesday, in case anybody has any questions. Okay, I will stop recording at this point.